This is lesson 1.5.8. The objectives are to solve single and multi-step inequalities in one variable and represent our solutions visually. The notes you need for this are very simple. You are just going to use Pemdas as you always would with any equation. And remember that P is for parentheses, E is for exponents, M and D are multiplication division. Always do that left to right. And A and S are addition, subtraction, again left to right. The only exception to solving an inequality as compared to an equation is that when you multiply or divide by a negative, you will switch the inequality sign. That's the only time that you will switch it, is when you multiply or divide by a negative. So think about that. That is different than adding or subtracting a negative. Nothing changes. It's just when you multiply or divide. Okay, so we're going to try 6 examples. Let's start off with a couple of basic ones just to get you into it. So on our first example, we have 4x, and I'm going to read this from where the variable is, which is on the left. So 4x is greater than 12. If I want to solve this, I need to isolate my x. So I divide by 4. Divide both sides by 4. Okay, and 4 divided by 4, we know is just 1. So we are left with 1x, which we can just write as x. We don't need to switch the sign because we are not dividing or multiplying by a negative. 12 divided by 4 is 3. Okay, so in order to graph this, I need to decide if I want an open circle or closed circle. Since my inequality is a greater than sign, that means I would need a open circle because I am not including 3 in my solution. So I will draw my circle. And let's get to the circles. And there we go. Let's draw a circle at 3. And then we need a line. So our line, it says we need all the values that are greater. See that? Greater than 3. Well, the numbers that are greater than 3 are going to be to the right of the 3. So I draw my line to the right, indicating that all my solutions are to the right of 3, but not including the 3, because I only want numbers that are greater than 3, but not 3. Okay, let's look at our next example. So in our next example, again, we need to isolate the x. So we need to divide by the -2. So divide both sides by -2. Always undo what's being done. And we are multiplying, so divide in order to undo it. -2 divided by -2 is just +1, or 1x. Now think about this. We just divided by a negative. What do we need to do? We need to flip the sign. Very, very important in order to represent our solutions correctly. 8 divided by -2 is -4. Okay, so if we graph this, again, we just have a greater than sign, so we need an open circle at -4. Okay, so you always put your open circle or your closed circle at your number to start, and then we need to draw an arrow. Luckily, we remembered to switch the sign, so our line will hopefully be in the right direction. X is greater than -4, therefore we need to draw our line to the right of -4 because all those numbers will be greater than -4. Okay, let's go on to examples 3 and 4. These are a little more complicated, but we can still solve them. So remember, in this case, we need to move the x's to one side, and then we need to move the constant terms to the other side. So I'm going to move my x's all to the left side, but it doesn't really matter. So in order to do that, I'm going to move the 3x by adding 3x to both sides. Okay, and then I draw my line and add down. So on this side I have a 2. 5x plus 3x will give me 8x. Be very careful to draw your inequality sign down, carry it down, and don't change it because we haven't multiplied or divided by a negative. The 18 stays the same, but if you'll notice, a -3 plus a 3 becomes 0, so that's gone. I won't even write it. All right, now I need to move the 2 over. The 2 is a positive 2, so I move it over by subtracting it from the left side, which means then I need to subtract it as well from the right side. Okay, so now we have a positive 2 minus 2. That becomes 0 on this side, and I'll be left with 8x. So 8x, carry the sign down, doesn't change. It's greater than negative 9. Oops, that's not a 9. It's greater than negative positive 16. All right, so 18 minus 2, just fix that, is positive 16. Okay, our final step is to divide by 8 in order to isolate my x. Divide both sides by 8. And I will be left with x on this side because 8 divided by 8 is just equal to 1 or 1x. Okay, do I need to switch the sign? Not in this case because I did not divide or multiply by a negative. So my sign stays as greater than. 16 divided by 8 is 2. Okay, my final answer then is x is greater than 2. And now I can graph it. Since I just have a greater than sign, I will use the open circle at 2. And then I will draw my line. I need all numbers that are greater than 2, and those numbers would lie to the right of 2. Okay. Example number 4. In this example, I'm going to again isolate the x by subtracting 10 from both sides. Notice that I need to subtract the 10 because in front of the 10 is a positive. The negative that's behind the 10 goes with the x, not with the 10. Okay, and then I draw my line. 10 minus 10 leaves us with 0, so I won't write it. And then I have a negative x on this side. Carry my sign down. I have a less than sign. 13 minus 10 is 3. Okay, I'm almost done, but not quite. Notice that I have a minus in front of the x. That means I haven't solved for x yet. If there's nothing in front of the x, it's understood then that there is a 1 there. Okay, so if we have a negative 1 in front of the x, we still need to get rid of that. And we would do that the same as with any other number. We would divide both sides by a negative 1. Okay, and negative 1 divided by negative 1 goes away, turns into positive 1, and we would be left with x. Then be very careful what we do with the sign. Because we divided by a negative, we do need to switch our sign. 3 divided by negative 1 is now negative 3. Okay, so on our graph, I'm going to put an open circle because it's greater than at the negative 3. And then I will draw my line. I need all numbers that are greater than negative 3, so my line will go to the right. All right, excellent. Let's move on to the last two examples, example 5 and 6. In this example, I will do the same as I did the last time. I need to subtract 7 because I have a positive 7 and I want to move it to the other side. I'm going to move my constants to one side. Okay, and so 7 minus 7 gives me 0. That's gone. And I'll just be left with a negative 3x on this side. Make sure to bring down your sign. It's a less than or equal to sign. And that's the first time we've had that. So think about what kind of circle you will need to draw when you are representing your visual solutions. 16 minus 7 is then 9. Okay. Final step. I need to divide both sides by a negative 3. Okay. Negative 3 divided by negative 3 leaves us with positive 1 or positive 1x, which I can just write the x. Now think about our sign. We just divided by a negative, and that is our one exception. We need to switch the sign when we divide or multiply by a negative. So I switch the sign, and 9 divided by negative 3 is just negative 3. Okay, when we graph this, remember what I said? We now have a greater than or equal to sign. So when I go to my negative 3, I will need to fill in the circle as I want to include the negative 3 in my solutions. So my solutions are saying that I want numbers that are equal to negative 3 as well as greater than negative 3. Okay, so I fill in the negative 3 and then I draw my line. And let's get a line going. Maybe. And I will draw my line. For some reason, it doesn't want to draw a line today. There we go, to the right of negative 3. Okay. Final example. So a little bit different with this example. Our variable term is on the right. I could move it to the left, but since it's on the right, I think I'm going to go ahead and keep it on the right just to make things simpler. So I'm going to instead move my negative 2 over to the left. So I will add 2 to both sides. And I will add down. Negative 17 plus 2 gives me negative 15. Bring my sign down. And then I've got the 5x. Negative 2 plus 2 goes away. That becomes 0, so I won't even write it. Okay, my final step, in order to isolate x, I would need to do the opposite, which would be divide 5. Negative 15 divided by 5 gives me negative 3. My sign will stay the same because I did not divide by a negative number. It's a positive number. And I'm left with 1x. 5 divided by 5 turns into 1, which leaves me with 1x. Okay, so the tricky thing is we've been reading from left to right. In this example now, our variable is on the right. And remember in the last lesson I said read from left to right unless you have a variable, and then read from the perspective of the variable. Since x is on the right, I want to start there. So I have x, and then if I look at my sign, the smaller end is here. So I have x is less than negative 3. Okay, when I draw my circle, it's going to be an open circle at negative 3 because it's not a less than or equal to, it's just a less than. And then when I draw my line, the key is reading this correctly. X has to be less than negative 3. So what I want then are all numbers that are less than negative 3. Okay, this concludes your lesson on solving inequalities and representing their solutions graphically. Remember that you do it the same as you would any equation, with one exception. Whenever you multiply or divide by a negative number, you have to remember to switch the sign. All right, give the next practice a go, and if you need any help, please send me a message.